Hey everyone, welcome back to another video. So today we'll start a new chapter series which is called the Laplace transform. And today specifically we will do Laplace transform by definition. And without further ado, let's go to our first example. Hey everyone, so this is our first example for today solving equations using the definition of Laplace transform. And so let's rewrite our Laplace transform definition at the start. Laplace f of t is equals to the integral from 0 to infinity e to the negative s of t multiplied by f of t, and all of the inside the integral are multiplied by dt. And so we know our f of t is e to the t plus 8, and we just need to rewrite this down and substituting our f of t with e to the t plus 8 inside the integral as well, and multiply everything inside the integral by dt. And then our next step would be simplifying inside the integral, so everything is simplified. We can pull out the e to the 8 multiplied by the integral from 0 to infinity e to the negative s of t plus t, and multiply everything by dt again. And so we just need to take the integral of what's inside. So e to the negative s of t plus t will be 1 over negative s plus 1. Let's rewrite this as 1 minus s. Let's put a bracket here. E to the negative s of t plus t, and everything here goes from 0 to infinity and bracket. And then solving what's inside after we took the integral of it, we know that e to the 8 multiplied by what's everything by everything inside is just 1 over 1 minus s. This is negative 1. And so we just need to multiply our e to the 8 inside. We will get here negative e to the 8, 1 minus s. And for the sake, let's multiply uh, the numerator and the denominator with negative 1. So we will get here e to the 8 over s minus 1 with s greater than 1. And so this is our final answer. Hey everyone, so this is our next example of solving f of t using the definition of Laplace transform. And so we're gonna start with our usual first step, which is rewriting down our Laplace transform definition, which is Laplace f of t is equals to the integral from 0 to infinity e to the negative s of t multiplied by f of t, and everything inside the integral is multiplied by dt. And so let's plug in our f of t as usual. We have here t squared e to the 4t, or rather e to the negative 4t, is equals to the integral from 0 to infinity e to the negative s of t multiplied by t squared e to the negative 4t, and everything here is multiplied by dt. And so let's simplify what's inside our integral. We have here t squared, and let's multiply it out the exponents. We will get here negative s of t minus 4t dt. We can also take out the negative signs, which gives us a more simplified version. You can do this or you can just skip this, but I rather do this. So this is s plus 4 times t, and multiply everything by dt. And now let's just solve this using integration by parts. And so writing t squared down, writing e to the negative s plus 4 t. Taking the first derivative is 2t, taking the second derivative, which is 2, taking the third leaves us with 0, and taking the integral of this gives us negative 1 over s plus 4 e to the negative s plus 4 t. Taking the second integral gives us 1 over s plus 4 squared e to the negative s plus 4 times t. Taking the third integral gives us negative 1 over s plus 4 cubed e to the negative s plus 4 times t. And doing the signs, which is positive, negative, and then positive. And so we have here our answer to the integration by parts. Let's just rewrite it down here. Multiply t squared by negative 1 over s plus 4 times e to the negative s plus 4 times t gives us negative 1 over s plus 4 t squared e to the negative s plus 4 times t minus 1 over, or rather, let's just plug in the 2 because it's 2 times 1 over s plus 4 squared times e to the negative s plus 4 times t gives us 2 over s plus 4 squared times t and also times e to the negative s plus 4 times t. And then our third and last component will just be negative 2 over s plus 4 cube times e to the negative s plus 4 t. And don't forget, this goes from 0 to infinity. Now let's solve this. We know if we plug in infinity here in all of these three components, because they all have e to the negative of t, they will all just be 0. And so 0 minus 0 minus 0 is just 0. And minus, now we plug in 0 to all of these three components. Since the first and the second component here have t, so if we plug in 0 to t, they will just be zeroed out. And so let's focus on the third component. We have here e to the negative 0, which is just 1, and so we're just left with negative 2 over s plus 4 cubed. And so our final answer here, we have 2 over s plus 4 cubed with s being greater than negative 4. And so this is how you solve for this example of f of t using the definition of Laplace transform.